So this is my metric number and also my name. My name is Nur Shafinaz Q3 171110227. So this is the research question. Will eating more food makes the student heavier? So there is 10 student, UMS female student. They have weight and also age. So let's see. So this is the new research question is developed by me. Is there any relationship between age and body weight? KG of UMS female student. So this is the data summarization. So from this data summarization, we can see 10 sample data was collected from 10 UMS female students. Both are independent variables, which are age and body weight of 10 UMS female students. So this is the experiment design. So the first one is two independent variable, which is age and also body weight. You also have one sample size for each variables, and each variable has sample size of 10 students, and body weight and also age was obtained from each student. So this is the scatter plot. We use this scatter plot to determine the relationship between age and body weight. So the x-axis is the body weight and the y-axis is age. So from this one you can see the strength is strong, little bit strong here and weak here. So if you draw a line here, we can form, when we draw a best line of it, the point may move along the line also. So the direction is upward, which is strong positive direction. So this is the explanation. Is to determine relationship between two independent variables, age and body weight, and from the plot there is a relationship between two independent variables. So we use Pearson correlation test. So through this relationship between two independent variables can be determined. So we have data type of two or more continuous variable, which is age and also body weight. So this is the normality test. So normality test is normal as the p-value larger than 0.05 and will not reject the null hypothesis. So there is no significant difference between age and body weight kg. So this is more than 0.05 for both data variables. So assumption, two or more continuous variable, which is age and also body weight. So each of the data have values and they also independent. So this is the null hypothesis. There is no relationship between age and body weight of 10 UMS female student. There is a relationship between age and body weight of 10 UMS female student. So this is the criteria. Alpha is 0.05. This is a one-tail test. So in this scatter plot, the distribution show positive and strong relationship between both variables. So in normality test, we do not reject the null hypothesis as the both data variable have p-value greater than 0.05. So we do not reject the null hypothesis and we accept the alternative hypothesis, which is there is a relationship. And we do not reject H0. We reject the alternative hypothesis, means that there is no relationship between both variables. So we move on to the so we set the directory and run. We also create a project and that is in CSV file run. Okay, and we structure the object and summarize the object and enzyme the object. You can view you can view, so you can explore the chart, the data, and so we structure the object with the body width, we summarize them, we structure object with age and summarize them. So we use Shapiro test for normality test. So we run sorry. So when we run the test, so this scatter plot is being produced. Thank you, Doctor. I cannot run the regression because there is error. So I want to make some marks, so I did Bayesian regression test, even though there is a error in it. Thank you, sir.